Okay, we're going to start 12.6. It's basically titled Special Products. And pretty much it deals with shortcut ways for multiplying two binomials. And the first way they're going to talk about is called FOIL. Some of you may have already heard of it. That's spelled F-O-I-L. And we will actually, I'm going to teach you this. You don't have to use it. I use it, but it's equivalent to this. So let's actually do 1A, the method I taught you to do it. So this is 1A, and we were to multiply x plus 7 times x minus 12. Well, I told you to take the first term in the first factor, which is the x, multiply it by the entire second factor, which is not x minus 7, sorry, but rather x minus 12. And then take the second term in the first factor together with its sign and multiply it by the second factor. When we do that, we get x times x, x squared. X times minus 12, minus 12x. Plus 7 times x, plus 7x. Plus 7 times minus 12 is minus 84. So let's actually look. Let's compare these, my result right here, and do this a different way. So the FOIL stands for first, outer, inner, and last. So I'm going to tell you what those mean. So my first terms, the first refers to multiplication of the first terms in each of these factors. So x plus 7 is a factor, x minus 12 is a factor. So the first term says multiply both of those two first terms together. And I get x squared. Then it says multiply the outer terms. So the outer terms are going to be the x and the minus 12. So that's outer. So x times minus 12 is, it's supposed to be equals here, is equal to, well, maybe I should have kept it the same color. So x times minus 12 is minus 12x. Let's choose another color, green. So the inner term is these two terms right here. That's the inner. So I multiply plus 7 times x, get plus 7x. And finally, I do the last terms, which are, sorry, not this one. So if the x and the x are the first terms, then the last terms are the 7 times the minus 12. And I get minus 84. So we have literally the exact same result. In both cases, drew right through it, we still have to simplify, and the simplification is always going to take place for the middle terms. Minus 12x plus 7x is minus 5x, and then I have 12 minus 12 times 7 is minus 84. So FOIL and the method I taught you are identical. So the question is whether you want to always do it this way or remember FOIL. FOIL is easy enough to remember. First, outer, inner, last is easy enough to remember. First terms, outer terms, inner terms, last terms. The only thing I can say in favor of FOIL, and the reason I do it, is because this is easy for head calculation. You can look and write. Up here, I usually find it's much easier to write this intermediate step. And that's all there is to it. All I'm going to do is, since you already know how to multiply, and there is no requirement to know FOIL, but let's go ahead and FOIL the remaining one, just so you can see its use. And then you all get to decide what you want to use. So this is 1b. So we have 3x minus 1 times 2x plus 5. So I'm just going to FOIL this. So the first terms, 3x times my 2x gives me 6x squared. My outer terms, 3x times 5 is plus 15x. That's outer. My inner terms, is my minus 1 and 2x. That's my inner terms. So it's minus 2x. And then the last thing is my last terms, which is my minus 1 times 5 minus 5. So the answer is 6x squared plus 15x minus 2x is plus 13x minus 5. So let's do number C the same way. So we have 2 not 2, that's an A. A minus 2B times A plus 12B. So again, we're just going to do all of these by FOIL just so you can see FOIL used. So my first terms are my A times my A. That's my first terms. So A times A is A squared. My outer terms is A times 12B. So A times 12B is plus 12AB. My inner terms is minus 2 times minus 2b times a, so that's minus 2, and I'm going to write my variables in alphabetical order, and then my last terms is minus 2b times 12b, which is minus 24b squared. So again, I have to simplify my middle terms. But 12ab minus 2ab is 10ab. And we have our result. And finally, the fraction. Yeah, we'll do the fraction because it's really not so bad, because we're multiplying. Now, the only simplification we'll have to do is when we add the middle terms, but let's just see how it turns out. Again, using FOIL. FOIL only works really when you have a binomial, that's a polynomial with two terms, multiply by another binomial, which is a polynomial of two terms. So let's get us some room here. So my first terms, my f term is x times x is x squared. My outer term, sorry, O comes next, FO, is x minus 1/6. So that's minus x divided by 6. Or if you'd rather write that as minus 1/6 times x, you're fine to do so. My inner terms are 3/7 times x. So that's plus 3x over 7. So we will have to simplify those. And then my last terms are 3/7 times minus 1/6. So that's minus 3, and 7 times 6 is 42. So we have to simplify this. So here, let's use one of my theorems about the LCD. The LCD of 6 and 7 is always greater than or equal to the largest of the two terms, and it's equal to their product if the two terms share no common factor. Well, since 7 is prime and greater than 6, they share no common factor, so the LCD is their product, which is 42. So I'm just going to write 6/7 minus x6 plus 3x7 is going to be over a common denominator of 42, and then minus 3/42. So what I do is now I multiply, since this is a product, 42 divided by 6 is 7, and 7 times minus x is minus 7x. 42 divided by 7 is 6, and 6 times 3x plus 3x is plus 18x. So now all we have to do is simplify. So this is going to be a plus right here. It's plus all of this term. So what do I do? What do I have to simplify? I just have to add the numerators. So minus 7x plus 18x is the same as 18x minus 7x. So that's 11x. And it's divided by 42 minus 3 over 42. So that's one way to write the result. Another way is just to write it this way: x squared plus 1142 times x minus 3/42. And that's good enough. I know some of you might, it's possible some of you might want to write it in a different way, and it's equivalent. And of course, I don't care. My math lab may disagree. you might want to write it as plus 11x minus 3 over 42. And the reason we don't want that is this is a polynomial. In particular, it's a trinomial. It has 3 terms. There's the first one, it has degree 2, coefficient 1. Here's the second term, it has degree 1, coefficient 11 over 42. And here's the constant term, it has degree 0, and its coefficient is itself, it's minus 3 over 42. That can be, of course, minus 3 over 42 can be reduced to minus 142 divided by 3, 1/14. So it's probably best to write this as minus 1/14. I'm not going to bother to erase it though. So here is the special products. So basically the first exercise was just teaching you how to use the FOIL method. And the FOIL method is optional. Now what I'm going to teach you next, well, it's sort of optional, but I want you to really learn this. It's so important that we really emphasize doing it. And if you try to shrug it, then you'll pay for it down the end. So what we're going to do is we're going to learn a special, they're called special products. And really what the end result is we get a formula. So if you have a binomial, so let R and S be polynomial terms. For example, variable terms or constant terms. Either one. So for you guys, we're going to stick to this. R and S are going to be polynomial terms, for example, variable terms or constant terms. I didn't write that very good. It's not my day today. I'm not able to write straight, and I don't know why. Maybe I'm sitting at a wrong angle. So I'm going to give you a formula. So R plus S squared is equal to R squared plus 2RS plus S squared. And the second formula is very similar to the first, and both of these should be memorized. Pretty much you memorize one and you got the other, because the only difference is the minus sign. That's R squared minus 2RS plus S squared. So those are the special products that we want to look at. And it deals with squaring of a binomial, squaring of binomials. So again, this is a math class, so I at least have to show you how we derive R plus S squared is equal to this, because you might at some time forget, and you can just find it on your own. So we take R plus S squared. Well, that's shorthand for R plus S times R plus S. So since FOIL method is on stage, R times R is my first term, so I get R squared. My outer term is R times S. My inner term is s times r, which I'm going to write in order of r times s. And my last term is s times s, which is s squared. So that simplifies to r squared. Rs plus rs is 2rs. And my last term is s squared. And that's identical to what I have right here. So we're going to be using that formula. It's really, really, really nice to have memorized. Why? Because math tests are timed. And, well, indeed, you could work it out this way, literally. You could work it out this way when you're given this side. But like all things in math, you're not always going to be given the left-hand side. Sometimes you're going to be asked to factor something, and we'll talk about factoring very, very soon. I think it's the next lecture. And you'll be given this. And you don't want to bother to factor it. You want to be able to recognize it and go immediately and say, well, it's equal to r plus s squared. So let me recap. If we lived in the world where we were always given the left-hand side, then we wouldn't even bother, I don't think, to remember special products. Although some of you, if you were doing a lot of this, would remember it. You could just go ahead and multiply it out, FOIL it, and you could come up with the answer. But we don't live in that world. Every time in math, when there is an equal sign, sometimes we're going to be given one side of the equal sign and be expected to produce the other side. So that means in the future, you're going to be given this side and you're going to be expected to produce the other side. And that's the reason this is important. So let's take note and use that. So I'm going to go ahead, and you should have it on your notes, but I'm going to write one of them up here. One of the formulas up here. And you should already know how to go from one formula to another. Remember, r plus s squared. So that's going to be our formula. Remember, the r and the s are, for us in this class, constants or variable terms, either or both. And when you get to intermediate algebra, we will literally let them be entire polynomials. So let's do 2a. We're not going to let them be entire polynomials for this class, though. We stick with the most simple of examples until you master those. So we're literally going to do this completely by the formula. So what I do when we're learning things by the formula, I write r plus s squared. Now, if you look at this formula in my MATLAB or in the book, they're not going to use r and s, they're going to use a and b. But then they use a and b as the variables for which they stand, and that's like you're using something to stand for itself in a different way, and that's a mess. Usually we can get by if I choose r and s. So I know what this is by the formula. So this is r squared plus 2rs plus s squared. So all I have to do is identify what my r is and what my s is. Well, my r is x, and my s is 4. So with that in mind, by the formula, this is x squared plus 2, And here, if your R or your S is a constant term, you grab that one first, because this is the same as 2SR, because this is all multiplication, and the multiplication can be, the factors can be moved around. That's the commutative property. So in this case, my S is my constant term, so I'm going to put it and multiply it times 4, and then I'm going to put my X, and then I'm going to put S squared, 4 squared. So let's simplify this right here. We'll simplify it right here. There's nothing that can be done to simplify the x squared term, but 2 times 4 is 8, and 8 times x is 8x, and 4 squared is 16. So that's the answer. So I want you to study that for just a second, because I'm going to erase it. I want to leave all of this formula for me over here. So while you're erasing that, I'm going to kind of draw a little area over here that I want to keep. Okay, let's do the next one. Well, it's not on erase. Our next one is 2b. I'm going to do 3x minus 5 squared. Now I don't have the, I'll write it now. See, I'm nice. The only difference is that the middle term becomes minus 2rs. That's the only difference. Well, again, I'm going to compare it with my r minus s squared, and that's equal to r squared minus 2rs plus s squared. So what I need to do is find my r and my s. So r is 3x and s is 5. See, the negative signs match up, so the s has to be 5. So that's going to be equal to 3x squared minus 2 times 5 times 3x plus my s is 5. So if you want, you can come down here and remind yourself that r is 2x and s is equal to 5. I know that s there kind of looks like a 5, but you know it's not. So that's by the formula. We need to go ahead and simplify it. 3x squared, so this is a power of the product rule. We are using those exponent rules constantly. That's 3 squared, which is 9 times x squared. Minus 2 times 5 times 3 is minus 30. And 5 squared is 25. So not so bad. So here we're going to do number B. C, not B. We just did B. C. So for C, go ahead and try. As a matter of fact, I challenge you to pause it completely. If you're aggravated that these videos go long, you probably already learned that one way to do this is once I've given you two examples, pause it, work out the last two examples, see if you got them right by fast forwarding to the answer. If you got them right, you're good to go. If you didn't get them right, go back and watch the workout to see what you need to do differently. So C is, we have 5x minus 3y squared. So let's compare it to R minus S squared. In this case, R is equal to 5x. S is equal to 3y. So this is equal to R squared minus 2RS plus S squared. So knowing that, and knowing what my R and my S is, I can just write it down. That's 5x squared minus 2 times 5x times 3y plus S squared 3y squared. So again, let's simplify that. So all of this needs simplified. I'm going to simplify it down here. 5x squared is 5 squared times x squared. 5 squared is 25, and x squared is x squared. Now what do I do to minus 2 times 5x times 3y? I just put all of the constants together. So that's minus 2 times 5, which is minus 10, times 3, so that's minus 30. And I think people prefer to put the variables in alphabetical order. You just got to choose one and be consistent. And then we have plus 3y squared, and 3y is 9. 3y squared is 3 squared, which is 9y squared. Okay. I hope you got that answer. Now, let's do 2D. So I have 7a cubed minus 4 squared. Let's see if we can do it without writing the formula explicitly. I'm just going to name my R is 7a cubed, and my S is equal to 4. So R squared is 7a cubed, and that's squared. And again, this is a minus, so minus 2 times R, 7a cubed, times S, which is 4, plus S squared, which is 4 squared. So let's simplify. 7a cubed squared is 7 squared, which is 49. A cubed squared is a to the 6th. So minus 2 times 7 times 4. So minus 2 times 7 is 14. So minus 14 times 4 is minus 56. A cubed plus 16. And that's our answer. Okay. So this is going to lead to probably what I consider, this one's mandatory, one of the most important factorizations and special products in all of math. I've seen people taking Calc 3. I mean, once you're in Calc 3, you're pretty advanced, and they forgot this specific factorization, and they were really struggling on a problem. And I was at a different university, and I didn't want to walk into the room and say, here's the factorization you need, and then just leave, because of course they didn't know who I was or that I was a grad student. But this is really important. So what I'm going to do is I'm going to suggest we're going to discover something, and then I'm going to give you a general formula. So we're going to discover it by looking at 3a. So we're just going to multiply this one out any way we want. And again, since FOIL is kind of taking a highlight, we're going to multiply this one out by FOIL. As a matter of fact, why don't you try to multiply it out by FOIL without me doing anything? So FOIL is first, that's y squared, outer plus 3y, inner minus 3y, and last, minus 3 times 3 is minus 9. So we're going to simplify this, and notice how the middle terms cancel. Plus 3y minus 3y is 0. So it's y squared minus 9. And if you think about it, that's the same as y squared minus 3 squared. So this is called the difference because of that minus sign right there of squares formula I'm getting ready to give you. Sometimes they will say difference, that's difference of squares formula. Sometimes they will use the term perfect squares formula. And here it is. I'm going to give it to you. So again, we're going to use an R and an S. So R minus S. And R and S stand for the same thing. They stand for polynomial terms. Times R plus S is equal to R squared minus S squared. Now notice that this is one factor times another, so it doesn't matter if we switch the order of the factors. We still get the same thing. And maybe I should have did that in a different color. What I have is screen glare. Screen glare. You all don't have that because the computer is recording this, and there is no external glare for the computer to see. So this is difference. If I could just spell this morning, it's Sunday, people, in case you're curious. Sunday, April 19th. This is the difference of squares formula. So let's do it, use it to do 3b. So we're given 5x minus 1, 5x plus 1. So how you recognize this is the two polynomials are almost identical. The only difference is one has a minus. So number one, you're looking at two binomials. So one has a minus and one has a plus. So let's do that. That's going to be r minus s, r plus s, and that's going to be equal to r squared minus s squared. So the cool thing about this formula is literally the only thing you have to do is identify your r value. So your r value in this case, and my s value, notice, my s corresponds to 1. Same over here. Because the signs are the same, then you just take the value of the integer or the polynomial term. So r squared minus s squared is equal to 5x squared minus 1 squared. Well, 5x squared is 5 squared times x squared. 5 squared is 25, and x squared is x squared, and 1 squared is just 1. So that was a piece of cake. That was a piece of cake. So let's do 3C and D. So C, we have 2x minus 3/5. So in particular, if you have difference of squares with fractions, multiplying them out is so much easier. So r is equal to 2x, s is equal to 3/5. So this is equal to, I'm going to write it down here, r squared, which is 2x squared minus 3/5 squared. Well, again, using exponent rules, this is power of product rule. 2x squared is 2 squared, which is 4 times x squared. And I can use the quotient rule here. That's 3 squared over 5 squared, which can be further simplified is 4x squared minus 9/25. Not bad at all. These are really simple once you have the formula. So this formula is all of the formulas here. I'm going to say you're a fool not to try to learn them. You're just inviting error after error or making things so much harder work-wise in the future if you try to shug memorizing them. Now, how you memorize them, that's up to you. Everyone has different ways to memorize things. I've had these memorized for years. I have no idea what I use to memorize them, so I can't help you there. So this is 3D. And we have 10x minus 7 times 10x plus 7. So clearly these are two binomials. The only difference is the sign between the two terms. So this is 10x squared. Why? Because r is equal to 10x and s is equal to 7. So by the power of a product rule, this is 10 squared, which is 100, times x squared, which is x squared, and minus 49. So all of those were really pretty straightforward. So we have one more page where we're going to mix these techniques together. So I'm not going to write the formulas anymore. You all should have them written down on a piece of paper on your own. And let's kind of look at these. Multiply by using special products. So let's look at B and C. There is no special product that you can use for B and C. What they're wanting you to do for B and C is use FOIL. And we've already used FOIL, so we're not going to use B and C. We can use the special product on A, because that's a binomial squared. And if we look at D, that's the difference of squares. So we're just going to do 4A and 4B, and you all should be able to do these on your own. What I will do is I will work out B and C at the very end. If you feel confident, you can turn off the video before I work those out. So N plus 13 squared. R is equal to N. S is equal to 13. So R squared is N squared plus 2 times S times R plus S squared. So I just have to simplify it. N squared, there's nothing to be simplified. 2 times 13 is 26N. And 13 squared is 169. So we did dispatch that one pretty easily. So now let's do 4D. And that's 3x plus 5. So again, 2 binomials. And they're identical except the signs are different. Well, my R here will be 3x, and my S will be 5. So that's equal to R squared, which is 3x squared, minus S squared, which is 5 squared. No, you're right, I did not have to put the parentheses down there, but it does not hurt. So 3 times x squared is, by the power of a product rule, is 3 squared, which is 9, times x squared, and 5 squared is 25. So that's it for 12.6. For those who want to hang on just a second, I will go ahead. It's completely up to you. Of course, I'll never know one way or the other what you do. I'll do 4b using FOIL and C using FOIL. A minus 4y times A plus 11y. Well, my first is A times A, which is A squared. My outer is A times 11y, so that's plus 11ay. My inner, let me move down here, so that's my inner. Minus 4y times A is minus 4. I'm putting the A first. And then my last, minus 4y times 11y is minus 4 times 11, which is minus 44, y times y, which is y squared. So the only thing we have to do is simplify this middle, these two middle terms right here. But 11ay minus 4ay is plus 7ay, and then at the end I have minus 44y squared. And 4c, again just using FOIL. T minus 2 times t plus 13. Well, my first terms, t times t, so that's t squared. My outer term is t times 13, so that's 13t. My inner term is minus 2t, and my last terms is minus 2 times 13 is minus 26. So all I have to do again is just collect like terms and simplify on the middle terms here. So I get t squared, 13t minus 2t is plus 11t minus 26. And that's all we have for 12.6. I will give you the heads up right now for 12.7. We only do a few of those. It will be really, really short. And then at chapter 13, we will start factoring. And that will require your greatest attention, but I've made it as easy as I know how.